right, so we're going to factorize this over C. That means that we're going to end up with some complex numbers as factors. So the first step here to factorizing z squared, that's z, z squared plus 4z plus 13 is to complete the square. Now remember, to complete the square, you take your b value, you halve it, and then you square it. So in this case, it's 4 over 2 squared, 4 over 2 squared, that's going to be 4. And then you add and subtract that. So it looks like this. Z squared plus 4z plus 4 minus 4 plus 13. So you can see I've added here and I've subtracted here. So what that creates for us is a group of 3 terms here that can be that are a perfect square, and a group of terms here that we can group. So z squared plus 4z plus 4, that's going to be equal to z plus 2 squared. Now, the 2 comes from here, the 4 divided by 2. That number there is going to be this number here, always when you complete the square. Of course, it's always just going to be the square root of whatever this number is another way to think of it. All right, and minus 4 plus 13, that's plus 9. So I have this factor here, z plus 2 squared, and I have this plus 9. And you might be wondering, where is this over c? Where is this complex number going to come from? I'm going to use some sort of mathematical trickery to make it appear. So z plus 2 squared, and then I'm going to put in an I squared here. Now, I squared, think about what I squared is. I squared equals -1. So I'm going to take 9 and I'm going to multiply it by -1. So it's 9. So now that becomes negative 9i squared. Well, that becomes 9 times -1, which is -9. But if I turn this into a negative, negative 9i squared is -9 times -1, which is equal to 9. So all of this is to say that 9 is equal to negative 9i squared. So I'm not breaking any rules here, but I'm able to insert an I squared by changing this sign here as well. 9 equals negative 9i squared. So now I have my imaginary number here, that I can start working with. So we completed the square up here, which is a skill that you probably need to practice a little bit. But also, if you look here, we have z plus 2 squared minus 9i squared. Now, let's take another little look at that. That's actually the difference of 2 squares. The difference of 2 squares. So you should remember that a squared minus b squared is equal to a plus b, a minus b. So what that means here is that this is our a squared, so it's going to be z plus 2 plus the square root of this, which is 3i. Probably make that a little bit clearer here, just by adding in an extra line. Z plus 2 squared minus 3i all squared. Okay, so that's 3 squared, I squared, which is 9i squared. All right, so now, difference of 2 squares. That's going to be z plus 2 plus 3i times z plus 2 minus 3i. And so now we have a fully factorized z squared plus 4z plus 13 over c, which means over the complex numbers. We've got 2 complex answers, z plus 2 plus 3i and z plus 2 minus 3i. A few little skills in there. Give it a crack.